Hello everyone. In this lecture, we are going to see about the energy conservation topic. This is Ben Christopher, Assistant Professor to the Department, PSNC. So, the outline of the presentation is, I am going to explain about the energy and types of energy, various forms of energy, utilization of energy, and what are the energy conservation ways, and how to prevent it, how to prevent the energy, and why the energy should be conserved, and what are the steps in energy conservation, and what are the future trends we are following in energy conservation, and tips for energy conservation. So with this, we are going to signing into this presentation. First, the energy. So energy is the ability to do work. Energy can be neither be destroyed not only be changed from one form to another. So in this regard, the energy can be neither be created nor be destroyed, but only changed from one form to another form. So what are the different types of energy, how it is categorized in the sense? So initially it is categorized into three types, that is primary and secondary, and in the second part it is classified into commercial and non-commercial, and next it is renewable and non-renewable energy. So primary energy and secondary energy classification holds one of the important categorization, that is, it is basically available in nature and whether it is artificially made. Okay, primary energy, so it is basically available in the nature, and it is one of the resources taken from the fossil, and which is especially coal and petroleum. Coming to the secondary energy, so secondary energy is basically the extracted form of energy, so from the primary energy. So especially it is electricity from that is extracted to the generated technology by means of coal and petroleum products. And coming to the second categorization, the commercial energy. So the commercial energy which is the available in the market, and especially it is electricity which is now traded over, similar to the financial terms. Now we are trading the electricity by means of energy exchanges. So the major players are consuming energy and distributing energy to the consumers, and industrial players are consuming energy and they are using for this purpose. So commercial energy, which is termed basically in the form of finance. And coming to the non-commercial energy, those are not available in the market, not available in the purchase, for the purchase, especially for the public concerns, they are not available. So one of the best example is the nuclear energy. And coming to the renewable energy, so renewable energy can be generated, it cannot be ended. And coming to the non-renewable energy, it cannot be generated, it is exhausted. The basic examples are the solar, wind and hydro. So also the beneficial of this renewable energy is, the renewable energy is pollution free and it is free of cost and it is continuously available. However, it is inherent, they are inherent and intermittent, so they are highly available in the natural areas, and it is totally free of cost. And coming to the non-renewable energy, it is a coal and petrol. So they are highly non-renewable, they are fossil deposits, they have been exhausted till days. So these are non-renewable resource form of energy. Coming to the various forms of energy, so still we are in previous slide we seen about the types of energy. Here what are the various forms of energy, that is potential energy, kinetic energy, thermal energy, electrical energy, chemical energy and nuclear energy, light energy and sound energy. So coming to the potential energy, so the energy which is stored by virtue of its motion or in the gravitation, it is being stored. We cannot possess the energy, we cannot take the energy from it, and then we cannot use it via direct means. By converting this potential energy into this kinetic energy, we can play so with our engineering technology, and we can extract it, we can use it for our day-to-day purposes. And coming to the thermal energy, it is the one form of heat energy that is generated either by means of fire, either or by the sources of sun or any external sources. And next, coming to the electrical energy. So electrical energy is the form of energy where most of the useful works are done. Here the flow of electrons is used for generating electricity and thereby doing the nominal work. And coming to the chemical energy is the energy that is present in the fuels, basically the coal, petroleum products and many fuels, ethanol. So these holds the chemical energy components. And coming to the nuclear energy, this is the energy of the radioactive components, so radioactive materials that is present in the universe, and this energy is having high energy density. And coming to the light energy, light is basically it is a source of photons. So this photon can be used to generate the electricity and used for several applications. So light energy in present days plays an important role. And coming to the sound energy, it is the major applications are sonar. So acoustics based lot of technologies are there. So these are the various forms of energy, and these energy in terms should be conserved. So coming to the potential energy, the best example is the dam. So when we store the water in the dam, it is basically the potential energy present in the particular area to the limited boundary. And when this boundary is released, when this boundary is open, so when the water flows through this pipe or penstock, it becomes a kinetic energy, and this kinetic energy in turn is converted to the mechanical energy by means of a turbine and generator setup, and the turbine converts this mechanical rotation into electrical energy by means of a generator, and which is boosted by means of transformer, and which is transferred to the main electricity grid. And coming to the examples and applications of thermal energy, so thermal energy we can see it is extracted from the heat sources. So thermal energy, the examples are IC engines, that is the internal combustion engines, so where automobile and traction systems are used, and stoves for cooking applications. Coming to the chemical energy, the petroleum fuel and batteries, especially lithium, lead acid, so comes under this chemical energy. And coming to the electrical energy, some examples of electrical energy applications are, so the lights, the motors, the generators and speakers. And nuclear energy, the nuclear power plants and manufacturing process for a lot of hydrogen extraction, hydrogen refining technology. So this nuclear energy is highly used. And coming to the applications of light energy, so power plants, that is especially the solar power plants, and the major part of this light energy is the application is scanning and X-ray applications. So next part is the sound energy. The application areas are entertainment zones and the sonar for navigation. And some of the most useful form of energy. So in the previous slide we have seen different forms of energy. So but however, the most useful form or the term which is publicly commendable is electrical energy and heat energy. So the electrical energy by means of electrical vehicles, electrical gadgets, electric entertainment, sports, media and communication plays a vital role in the day-to-day life. So electrical energy is one of the important form of energy that we use in our day-to-day life. And coming to the heat energy, so automobile engines, so cooking applications, so these are our day aspects, and we have to follow this. For transportation we use automobiles, for cooking application, for eating we use heat energy. So these are the most useful and prevalent form of energy, that is one of the fundamental need of every human. So how the utilization of energy is increasing in the sense, in the I am categorizing this into three types, that is a pre-industrial society, industrial revolution and technological revolution. So in the pre-industrial society, so we are using uncontrolled or improper way of energy utilization. So the energy utilization made is highly uncontrolled and it is improper, and we can see from this. So a lot of thermal energy is wasted by means of an external combustion. So this should have to be controlled. And coming after the era of pre-industrial society, there comes industrial revolution. So the industrial revolution, the technicians or the engineers planned how to control or how properly the energy should be utilized. So in this concern, they developed the internal combustion engine in case of thermal, and each and every category of engineering has some controlled way of this type of energy utilization. And further, they have improved. Not this these machines does not give any higher efficient, and we cannot extract any maximum power. So further, they have designed more advanced technologies. For example, in the current technological revolution, that is in the industry 4 era, so they are searching for more and more better way for energy utilization. Especially it is optimal way of using every energy, every part of available energy. So in order to maximize the utilization, thereby achieving the higher energy efficiency. So this is one of the good example of the development of combustion methods from the pre-industrial society to the technological revolutions. So in the pre-industrial society, the external combustion methodology is used, which is highly very poor energy consumption technique. So and after this pre-industrial society, in the industrial revolution, the steam engines are introduced. So this becomes a somewhat external combustion, and after premeditated diesel engines are been there, they have developed the internal combustion technology, and thereby so industrial era just moved on to the technical revolution, and now it is in a very advanced stage of having a high better performance engines and high better performance systems that is available in the technological revolution of the thermal energy. And coming to the next concept, so of energy conservation. So however these energy are present and we are utilizing, so we have to conserve the energy, because the energy is one of the vital component in the present day. And coming to the excessive usage of this energy from the present day resources, there is a question mark of exhaustion of energy for the future candidates or for the future generation. There is a exhaustion. So in this case, we have to conserve energy. So coming to the general aspects, so from childhood we have been taught the principle of turning off devices or appliances when not in use. So this is one of the important thing that we have taught from our childhood, that we have to turn off the devices when there is no usage of it. So and next we adopt these practices not only for save money but also to reduce the consumption of energy. So we will adapting this not only for saving the money, but also we have to reduce the consumption of energy. So next, energy conservation. So basically is what, in the sense, it is an act of reducing the usage and wastage of the energy. To reduce the environmental impact on society, energy conservation measures are being imparted. So remember, you're saving energy, you are protecting the environment directly, in the sense. So how we can make this, in the sense, so if you consume less energy, the environmental entropy or entropy disruption is reduced directly as per the researchers. And if the things are being reduced, if the energy consumption is reduced, there is a fuel saving, and thereby leading to environmental protection. And what is the aim of energy conservation? Let's keep the things very simple. So the ultimate aim is moving towards carbon neutral or towards zero energy. So carbon neutral, in the sense, in the present day, in most of the energy extraction technologies is towards the combustion technologies, that is burning the fuel and we are extracting it, and the byproduct is the unburned hydrocarbon or the carbon dioxide emission. So this is the two byproduct, and both the product have carbon. So carbon is one of the dangerous things that contribute for the global warming, the climatic changes, and various other ecological disturbances. So the ultimate aim of energy conservation is to move towards the carbon neutral. So initially our part of this lecture is being completed at this stage. That is, energy conservation is the initial measure to be a step to the carbon neutral aim. So after energy conservation there is energy efficiency, and finally there is renewable energy, that is the ultimate consumption of renewable energy or maximum consumption of renewable energy comes into the play. So thereby no combustion fuels are used and the energy that is required for the human is taken from the renewable energy. So why energy should be conserved? So these are some of the points that highlight why the energy should be conserved. So first, as I said in the previous slide, to reduce the carbon footprints, the burning of fuel leak hydrocarbons and carbon dioxide emissions. So this affect the environment in a very high manner, so that we have to reduce the footprints of this carbon. So in order to reduce the footprints, we have to implement the renewable energy systems or alternative energy systems that produce clean energy. So for this we have to conserve the energy to balance climatic change. So as there is so before speaking into the balanced climatic change, we have to speak about the decrease in global warming. So carbon dioxide and other CFC emissions through burning the fuels or any refrigerants causes this global warming. So heating of earth. So as the heating of earth increases, so the radiation that is emitted from the sun adding with this global warming make the climate warmer for the human to feel. So this increases the temperature of the earth. So as a result of this, the climatic change happens, thereby unpredictable seasons can be expected. So in order to balance the climatic change, the global warming should be reduced, and for the global warming should be reduced, we have to conserve the energy. So to prolong the existence of fossil fuels. So in order to extend the life of the fossil fuels, we have to conserve the energy. So and next is the reduce pollution ill effects. So what are the pollution ill effects? So the pollution, for example, the cancer, the other respiratory diseases, and food poisoning and water pollution, and these are the various ill effects that is rise due to the pollution. So if we want to reduce the pollution, the energy should be conserved. So the energy that is being wasted should be conserved in order to reduce this pollution, to protect the environment. So as there is unburned fuels, as there is carbon dioxide in excess, so definitely when it comes to the earth again by means of acid rain. So this acid rain will enter into the rivers and damage the aquatic life, and this aquatic life, when damaged, it destroys the entire ecosystem of aquatic systems, and thereby the wild energy is disturbed, and thereby the human residence is being disturbed, as it is a common web chain. So everyone is being ill affected by the effects of this non-energy conservation process. So in order to gain the advantage of energy conservation, so we have to be very cautious to promote our health also. So what are the basic steps in energy conservation? So basically one has to modify the personal habits to reduce the energy consumption, and one has to maintain appliances to keep them working efficiently, and one have to replace inefficient appliances. So these are the three basic steps that a normal human can be following in order to reduce the energy consumption and in order to possess the energy conservation. And next, there are various energy conservation techniques in the present day in terms of engineering standards. So first, the building, coming to the civil engineering concepts, the energy is conserved by means of building and structural improvements. And coming to the electrical point of view, we are using energy efficient lighting solutions, so in order to conserve the energy. And coming to the heating, ventilation and air conditioning system, it corners the mechanical engineering or the thermal engineering concepts, so where we can conserve the energy. So in overall, so we use energy efficient appliances and equipments for conserving energy. So let me explain in detail about this building and structural improvements where we can use this improvements to conserve the energy. So coming to the insulation, it always deals about the heat flow that is coming outside the environment to the inside. So especially in summers we are following. So insulation, the types of insulation materials. So we are coating the materials. We are coating the home by means of these materials. That is a fiberglass. It is the form of plastic material, that is in the form of polymers. So we are using this fiberglass to protect the heat that is coming from the environment to our home, thereby reducing the usage of fans and air conditioning system. Similarly, foams. Similarly, cellulose. Cellulose is a combination of natural products, natural cellulose, both artificial cellulose are there. So it is a combination of carbon, hydrogen and oxygen compounds, and optimally pacing and this compounds we are making this, and these three, if used for insulation, can be better for the home to survive in a very hot conditions. So changing of windows and doors. So energy efficient windows, and most probably this technology is followed in the aircrafts. So double glazing, that is two glazing windows are being there. In the center portion there is splitting of this, there is vacuum or air. So this produce a prevention of the excess heat to come inside the room. So two advantages are here. One, using a large window we can maximize the inflow of the natural lightings, and we can reduce the heat that is flowing to this glazings. So there are two advantages. There is a hybrid advantages we can expect from this type of windows and doors. Also low E class. The E stands for the emissivity. The emissivity becomes very high, thereby the external reflection should be very high for these glasses. So this two technology increases the heat reduction in the room, thereby placing the energy efficiency a important concern. And coming to the weather stripping and ceiling leaks. So the temperature, the cool temperature or present inside the room is being maintained by using optimal weather stripping and ceiling leaks. And coming to the roofing and walls. So civil engineers can plan for a cool roof. So cool roof concept in the sense we can place reflective coatings, the coatings that should not absorb the radiation that is coming out of the sun. So if it is not absorbing, definitely we can say there is a high percentage of reflection coefficient of this material, there is no heat transfer between the buildings, and thereby having more cooled inner space of the home. And wall insulation, definitely similar to the cool roofs, as per the things we have seen in the upper area in this slide, that is fiberglass and foam are used as wall insulation materials, and we can prevent the excessive flow of heat that is coming out of the out from the radiation of the sun. And coming to the thermal mass, okay, here the mass of heat, it is either in summer it is stored and in winter it is stored and released during day and night respectively, and in the summer it is released and removed during the days and night respectively. And coming to the building design, passive solar building design, that is avoiding the maximum exposure to the sun. And building orientation and landscaping, that is all these aims to reduce the heat that is coming out of this sun radiation towards the inner comfort space for the human, so thereby reducing the flow of heat and ensuring the conservation of energy. So coming to the energy efficient lighting solutions, so there are in the present day the market ruling concept is the LED lighting. So LED lighting is highly efficient. So from this we can see there is 60 watt incandescent bulb can be replaced by the 9 watt LED. So the power consumption is nearly around less than 6 to 7%. It is a very highly less compared to the incandescent bulbs, thereby cost savings is achieved. Smart lighting system. So smart lighting system, here the more motion sensors, the occupancy sensors, the dimmers and timers are used as per the occupants who are present inside the room. And as I speak in the earlier slide, so natural lighting system, here the natural light from the sun is being utilized for maximizing the lumens that is coming inside the room, thereby optimal light flow is achieved. So this is done by skylights and lighting the various tubes that is connected to the exposure, sun's exposure. And coming to the lighting controls, so control is made optimum. So even though manual controls are precise, the automated controls become more and more precise and optimal. So automated and programmable control in assistance with the sensors and dimmers and timers, so we can achieve a maximum amount of energy conservation. And coming to the HVAC system, so coming to the mechanical part, so efficient HVAC systems, that is a variable refrigerant flow, optimal heat pumps. So all these concepts have proven to be highly energy conservation in terms of the air conditioning systems, and regular maintenance of this HVAC system and cleaning and replacing filters will also improve the energy conservation ratio of this mechanical systems. So, and use of energy efficient appliances and equipments. So we are mostly aware of this concept of 3-star and 5-star. Because 5-star ratings. So the star rating is basically the how much amount of energy is being utilized. So for example, 3-star rating, the energy consumption is more, and 5-star rating, the energy consumption is less. And in terms of energy conservation, the 3-star is highly energy consumption, so that the energy conservation is very much low, and for the 5-star the energy conservation is very high. So identifying the energy star labels and buying the energy efficient products is one of the important concept of this energy conversion techniques. And efficient cooking systems, the efficient cooking systems, the induction cooktops, the convection ovens, the microwave and toaster ovens, and the solar ovens, solar cookers are lot efficient technologies that are presently including in the market for the energy conservation techniques. And coming to the water heaters, so tankless and solar water heaters, so the tankless water heaters are now available in the market, and heat pump water heaters from the sources is from solar and thermal electric. So like that, lot of technologies are being there, so for energy conservation. And office equipment, energy efficient computers, monitors and printers, power management settings and smart power strips are some of the office equipment where the energy conservation is being followed. And coming to the various economic benefits and benefits of the energy conservation techniques, so economic benefits by means of energy conservations are reduced energy bills, return on investment. So the energy bills, either for a concern, either for a home, either for a utility, either for any of the company or organization, if we follow the energy conservation, definitely we can see the reduced cost of energy, and that is replicated in the reduced energy bills. And coming on the investment, so return on investment is very much high in terms of energy conservation principles. And coming to the environmental impact, definitely energy conservation plays a vital advantage for this environment, so that to lower the carbon footprint, and it contribute to the sustainable environment, thereby prolonged nature is maintained, and health and comfort. So by maintaining energy conservation, pollution is being reduced, and thereby the indoor air quality is highly improved, and the comfort levels, that is the temperature comfort levels or lighting comfort levels or sound comfort levels, are being enhanced. So what are the trends in energy conservation? So what are the present day trends in energy conservation? Demand for renewable energy solution. So what are the demands in the sense the businesses and individuals are mostly turning to the solar, wind and hydroelectric power as sustainable alternatives to traditional fossil fuels. So this services now enable the clients to generate their own electricity and reduce their reliability on the grid. So they don't depend on the grid for their energy. They will produce their own energy. So this is one of the first step to find energy conservation, that is the demand for renewable energy solutions. So and coming to the smart building technologies. So smart building technologies, in the sense, it includes IoT enabled service, that is the communication between each and every devices is being there between the controller or the manager of a particular smart building. So this system will improve the or reduce the unwanted energy consumption by a consumer or any utility systems. So this also done by energy management softwares and building automation system softwares. So most of the things are being automated. So what are the outcomes of the smart building technologies? In the sense, we can optimize energy consumption, improve the human comfort or the occupant comfort, and reduce the total operating cost of the utility or the energy manager. So future trends in energy conservation. So what are the future trends in energy conservation are energy audits and efficiency assessment. So coming to the next part, third part is it is energy audit. Energy audit it offers a conservation service markets. So to assess how much energy is consumed with a particular company or association or a home or a system, and assess for its efficiency, and this efficiency we can quantify and we can make appropriate decisions for the improvement, and so we can produce a tailored solution for it to give a suggestion for a particular concern. And coming to the building energy management system, the building energy management systems is now increasingly prevalent in the energy conservation service market. So this holds a lot of complex process, and here the building automation software plays a vital role. So these systems provide centralized control and monitoring of building energy use, especially in HVAC systems, lighting systems, and any other equipments that is in demand for energy conservation. And by optimizing the operation of these systems based on occupancy, based on weather conditions and other factors, BEMs plays a significant role in reducing the energy waste. For example, so if there is without occupancy, so if there is any consumption equipment is being turned on, so the building energy management system automatically senses and switch off it by means of IoT technology. And in other case, if the weather suddenly changes from summer to raining, so there is less need of HVAC systems. So similarly, these systems reduce the energy that is being consumed in terms of a waste. And coming to the next concept of the trends in energy conservation is green building certification. The pursuit of this is one of the vital concepts that the policy makers of energy are being undergoing. So the two certificates, especially the LEED certificates and the BREEAM certificates, is highly important. This is for green building, and this is a new concept of pursuit of this present day energy technology, where LEED is the leadership in energy and environmental design. This certificate is provided for the better energy and environmental practices made by the concern, and building research and establishment environmental assessment method is made for the good energy auditing practices. So these are the two vital certification or policy that should be attained by the building, especially in the urban areas, to offer good service for the both government and both for the environment. And it is one of the driving demand of energy conservation services. And coming to the next, these certification recognize buildings that meet stringent sustainability criteria. So very sensitive sustainability criteria in some urban areas they are following. So there the certification, that is a LEED and BREEAM, are highly important, including energy efficiency, water conservation and indoor air quality to promote the health and other benefits. So focus on energy storage solutions. So as the present and again in terms of conservation is focusing on energy storage solutions. So this is one of the good topic as the need for grid reliability and energy resilience grows. Energy conservation services are increasingly incorporating energy storage solutions. So battery storage systems allows for the capture and storage of excess energy generated from the renewable sources. So such as solar panels. So during the time of summer or any daytime, the energy is being excessively generated from the solar and that is stored in the battery, and if there is a demand during the night time, we can use during that time from this battery. This stored energy that is also can be used from the peak demand periods or when the renewable energy, especially in the for example if solar in the night it is not producing electricity, so we can use the excess energy that is stored from this energy solutions. So energy conservation at home, there are basically 12 tips for energy saving at home. So that is turn off the lights when leaving a room, use LED lights by replacing the incandescent bulb, switch energy efficient appliances, unplug devices when not in use, keep the thermostat at low temperature and reduce water consumption if it is not highly required, use smart and automated devices, switch to double glazing, look with very lid on or in a low lid, and use a smart meter to track usage, wash at a cold temperature, use solar power devices. So these practices will definitely lead to the energy conservation at home. So with this I am concluding this lecture. So if any queries regarding this, you please contact me. Thank you.